Today we are going to discuss about the mechanism of action for the penicillin. Last class we discussed about the stereochemistry. Now mechanism of action. Mechanism of action theoretically also we are going to be discussed, and in the structural way also we are going to be discussed. Listen carefully. See, for the cell wall synthesis of the bacteria, remember this, cell wall synthesis of bacteria. What it will be required means this combination of these amino acids will be required. With the help of here two enzymes are there, okay, that will be bind with the disulfide bonds. One is the N-acetyl muramic acid, another one is the N-acetyl glutamic acid. See, N-acetyl muramic acid, N-acetyl glutamic acid. Then on the N-acetyl muramic acid, what it will be present means this amino acid combination is present. This is necessary, vital for the cell wall synthesis of the bacteria. Very important for the cell wall synthesis of the bacteria. See here, what combination it will be have? Alanine, glutamic acid, glutamine. See, lysine attached to the glycine, glycine. Four glycines. Then D-alanine, then D-alanine. In the short way, you can remember that AGLA, A-G-L-A-A, like this. In the short way, A-G-L-A-A. AGLA. AGLA is Hindi word. Okay, that is the front one. AGLA means front. Okay, you can remember in the short way, A-G-L-A-A. That is the alanine, glutamine, lysine, alanine, alanine. This is the combination. Easy to write in the exam. And where it is present? It is present on the N-acetyl muramic acid. N-acetyl muramic acid. Now see, this enzyme, it will be play the vital role. Which enzyme? Remember the name, transpeptidase. Which enzyme? Transpeptidase. Now this transpeptidase, what it will be do means, it will be form the cross linkage between this and this D-alanine. How it will be? For example, see, it is coming to the D-alanine. It is coming to the D-alanine means this D-alanine, this bond, what it have to be do? It have to be break. It have to be break down. That's why in the form of D-alanine, it goes out, minus D-alanine. This one is coming means this is going out. One amino acid, it have to be loose. Then what happened then? It forms the cross linking. Just see. Cross linkage between what? This side chain of the glycine, which is attached to the lysine, with the D-alanine. With the help of which enzyme? Transpeptidase. It means what? Transpeptidase, it is helpful for the formation of the protein, means cross-linking of the protein. With the help of what here? Which enzyme? Transpeptidase enzyme, which is going to form the peptide bond in between this amino acid and this amino acid. That's why it is called as the transpeptidase. This is called as the cross-linking. What it is called? Cross-linking. By this cross-linking, what happened? This protein complex, it is going to be formed. For what purpose? For the cell wall synthesis. Remember this, cell wall synthesis. Of what? Cell wall synthesis of the bacteria. Cell wall synthesis of the bacteria. It means what? When the cross linking will be formed with the help of transpeptidase enzyme, then it will be helpful for the cell wall synthesis, this protein. Cross linking, once it will be happen means cell wall, it is going to be formed around the bacteria. Cell wall, it is going to be formed means the growth of the bacteria, it is going to be increases. growth of the bacteria, it is going to be increases. That is the use of transpeptidase. That's why what we are using to prevent this enzyme? To prevent this enzyme, we are using the penicillins. What we are using? Penicillins. If we use penicillin means penicillin form the bond with the transpeptidase. Once the penicillin form the bond with the transpeptidase means there is no cross-linking. There is no cross-linking, means cross-linking it is prevented. Cross-linking prevented means no cell wall synthesis. No cell wall synthesis. No cell wall synthesis means growth of the bacteria, it is going to be prevented. Then how? In the chemistry way we will be discuss how it will be formed. Enzyme it is there. Which enzyme? Transpeptidase. Because penicillin it is going to be bind with the transpeptidase. This is the transpeptidase enzyme. It is having the nucleophilic group on the transpeptidase enzyme. That will be attack on this pi bond. Because double bond, that is the carbonyl carbon where it will be attack. Once it will be attack here means what happen? It is having the pair of electron already. This pair of electron helpful for the formation of new bond here. New bond will be formed with the pair of electrons. Means enzyme, then nucleophile. It is forming the bond. Then it will be forming the bond with this means this extra bond is here, no? Here double bond is there. One bond it is moving on this oxygen. Oxygen already it is having the two pairs of electron. One more pair it will be moved from here to here. Means total how many pairs? Here. This double bond it is moving here. One pair, two pair, three pair. Three pair of electrons. See this. Then this nucleophile having the hydrogen also. That's why it liberate hydrogen minus H plus. Now hydrogen it is going to be liberate here. Okay, minus H I wrote. Now next what happened? Next step you can see. This step is over. Enzyme with the nucleophile forming the new bond. This pair of electron, this double bond moving here. That's why here it is going to get the extra pair of electron. Now this hydrogen coming into the picture. Now this hydrogen, this bond it is going to be moved. Where it is going to be moved this bond? This bond it is having the extra pair of electrons. Bond is nothing but pair of electrons. Okay. That pair of electrons giving to whom? After. See this pair of electrons it is having extra pair of electrons. This pair of electron where it will be moved? It will be moved here and it is going to be break. This bond it will be moved here. Means what happened here? It is going to be form the double bond. Because bond it was moved here. Now see here. This is the same. Nucleophile and enzyme. Now this hydrogen where it will be go? Here. Because once it was broken means it is the deficiency of the electron. Okay. Here hydrogen it is having the electrons. Now it will be bind with this hydrogen. See which enzyme this one? Transpeptidase. Which one is going to be bind? Penicillin going to bind with transpeptidase. See penicillin binding with transpeptidase. Why transpeptidase? It is having the nucleophilic group. That's why it will be attack on this. Then it will be forming the complex of the enzyme and penicillin. Complex of what? Enzyme plus penicillin. Enzyme means which enzyme? Transpeptidase. This complex once it is formed means what happened? There is no transpeptidase to be cross-linked. No cross-linking. No cross-linking means no cell wall synthesis. No cell wall synthesis means no growth of the bacteria. This is the simple. Okay. In the chemistry way also we discuss the mechanism. In the normal way also. In the chemistry way, penicillin is responsible to bind with transpeptidase. That's why transpeptidase having the nucleophilic group, it loves the nucleophilic center, electron deficient center. Carbonyl carbon always electron deficient. Easily it can be attacked. It is attacking, it forming the new bond, then that pair of electrons moving to be here on the oxygen. Two pairs becomes now three pairs And next what happened, this hydrogen, it will be going to be attached to this nitrogen, means this bond, it will be moving here. When it will be moved here, it forms the double bond. I am writing this side or this side, no problem. Moving here, then it will be form the double bond, then the complex of this enzyme with the penicillin. It means no more transpeptidase enzyme to react on this step for the formation of cross-linking. There is no more transpeptidase enzyme. Transpeptidase enzyme prevented by whom? Prevented by the penicillin. That also covalent bond it will be formed, remember. Covalent bond means once it will be formed means it is not going to be break. It is very strong bond. It is not leaving to the transpeptidase. It is asking transpeptidase, stay with me, don't go. It made the friendship with the transpeptidase. Who made the friendship? Penicillin. Penicillin is like a police. It is going to guard the transpeptidase. Transpeptidase is the thief. Thief, what it will be do? It will be building this one, cross linkage. For what purpose it is required? For the cell wall synthesis. That is going to be prevented. That's why penicillin, P means penicillin, police. It is going to be caught the transpeptidase. Then it will be, once it will be caught means it will be holding to that enzyme by forming the complex. That's why it never allow, there is no more transpeptidase enzyme for the cross-linking. That's why no cell wall synthesis. Then the bacteria, it is going to be die. I hope you might be understand. Okay, thank you.